Before we can do the completing of squares operations, we need to review the definition of square root so that we completely understand where that comes from. We all know that the square root of 9 equals 3, but what we don't always think about is the true definition of square root. So the true definition of square root is actually the positive root. And so the real definition is the square root of 9 is actually equal to the absolute value of 3. And algebraically, it looks more like this. We say the square root of a squared is equal to the absolute value of a. And so when we think about that, when we recognize that the square root of 9 equals the absolute value of 3, well, we know the absolute value of 3 is simply 3. Well, in the algebraic representation, though, the absolute value of a is equal to plus or minus the evaluated value. In this case, we don't have an evaluated value. So let me give you an example. So here we have a squared equals 9. Well, if a squared equals 9, then in order to find out what a equals, we simply take the square root of both sides. Okay, so since we take the square root of a squared, the definition of that is that it will equal the absolute value of a. And we also know that the square root of 9 is equal to the absolute value of 3, which indeed equals 3. So now we know that the absolute value of a equals 3. Well, therefore, a can equal plus 3 or a can equal minus 3 or negative 3. So this is where we get that nomenclature where we would say a equals plus or minus 3. Now we cannot say up here on this problem, the square root of 9 is not equal to plus or minus 3. That is not true. The square root of 9 is equal to the absolute value of 3, and the absolute value of 3 is equal to 3, because the definition of square root is the positive root of the radicand. Let's look at another problem. So here we have a square on the left side and a square on the right side. So to get our a alone, we have to get rid of the square. So to do that, we take the square root of both sides. So the square root of the left side is actually the absolute value of a plus 2, because the square root just got rid of the square. So we're left with the absolute value of a plus 2 equals the absolute value of 5. Now we typically don't write the absolute value of 5 because we know that the absolute value of 5 is just 5. But just to emphasize the point here, I'm writing it that way. So now because we know that the absolute value of 5 is simply 5, we're going to take, just like we did these absolute value equations before, we're going to take the inside out, a plus 2, and we set it equal to its evaluated value of 5. And we also take a plus 2 and set it equal to the negative of the evaluated value. So now we can solve for a, and we'll find out that we have two different answers. So we subtract 2, and we get a equals 3. We subtract 2 down here, and we get a equals negative 7. Just like we had done previously in our absolute value problems earlier in the semester. Let's try this one. It's the same kind of situation. We have a square on our a, and so we want to undo that square by taking the square root. And whatever we do to one side, we do to the other. So the square root of a minus 5 squared is equal to the absolute value of a minus 5 And that's going to equal the square root of 37 because it's not a perfect square, so it's just the square root of 37. Okay, so now we have to deal with figuring out the a, and in order to do that, we pull the inside out of the absolute value. So we have a minus 5, so we take the radicand out, a minus 5 equals the positive of the evaluated value. And we also say a minus 5 equals the negative of the evaluated value. And so now we can solve both of these. We add 5, and since those are not like terms, we get a equals 5 plus the square root of 37, which is a perfectly logical answer. Down here, we add 5 to both sides, and here we get a equals 5 minus the square root of 37, again, a perfectly logical answer. Just for practice, I need you to work this one on your own and then resume the video to see the answer. So here's the answer, and you'll notice that this square root can be simplified. So you always want to try to simplify your square roots, but it's no different than what we've done before. So the real issue here is making sure that we identify this as being the absolute value of the radicand, the square root of the radicand. All right, and that's what we've done here. Now this 72, as we have seen before, simplifies out to be 6 square roots of 2. And so now we take the radicand out, set it equal to the positive of the evaluated value. We take the radicand out and set it equal to the negative of the evaluated value. And we get our two solutions right down here.